I'll do my best to be at least interesting. I am a dinosaur. Not one quite so predatory or lithe as that one. I'm more of the big brontosaurus type who is protected from predators by bulk and eats tons of food every day and maybe isn't even real. But the reason why I say I'm a dinosaur is because I've been in performance testing for a very long time. And performance testing as a discipline kind of got launched in the mid-1990s in the client-server era when we went to dozens or hundreds of users connecting to a server at the same time. It didn't seem that long ago until I started thinking about this and what year it really was, and it really has been that long. These days, I'm a product manager for a load testing tool called Cloud Test, and that's what I'm working on these days. I'm involved in the software testing communities and specifically the performance testing community for many years now, going back 10, 12 years. And this is what I'm involved in. So I work with software testing, which as a field has been greatly disrupted and has a lot of testers who are learning how to code automation or find another kind of work. Performance testing is a little different, and that's what this talk is about. We'll talk about how performance testing has changed to work in a continuous integration context and what's kind of changed about that discipline. Maybe give you some insights from the past that might help. We'll see how that goes. So this last one, the workshop in performance and reliability, this is a peer workshop that I work with other practitioners on. And I bring that up because I have to cite them in a minute because we had a meeting and we talked about this subject. So that's our rules for giving credit as everybody gets included. I am not a DevOps maven. That counts as a pun, right? I'm definitely not a Scrum bag. You're welcome to use that one. And I'm not somebody who's an expert on agile processes. I make my product work with Jenkins, and so I know a little bit about this world, but I'm a performance tester, and that's where I'm coming from. So these are my friends that we got together, and we talked about how to do early performance testing and how much different things have changed over the last few years. So they all get credit for a lot of what I say here as well, and we make a point of not pulling that back out. Oh, he thought of that first. We did come up with the term DevPops, though. That would be performance and operations and development. So the future just keeps happening. 10 years ago, even 5 years ago, I was still working with doing large-scale load tests at the very end of a development process before something went live. And as we know, there are still plenty of enterprises out there that are still doing their business this way. So hopefully that they'll get with the times pretty soon, or they don't end up like these dinosaurs here. Apologies, by the way, that they don't have feathers and what modern paleontology tells us about dinosaurs. These are also from a few years ago, I guess. So I think that when I trace this back, I think it all changed when the inmates took over the asylum. I mean, developers got to own the process for which they wrote code. And when that happened, it rippled outwards and kind of changed how everything went. So we know about deployment changing and ops changing. That's why we're here. The testing world, this was a huge deal because we went from a lot of people who sat at a mouse and drove software all the time to a world where, especially here in the Valley, where people don't do that anymore. If anybody does that, they're offshore, and those people have been replaced in most cases by automated tests. So I want to dig a little bit into what that means. And then, as I mentioned, we'll get to the performance testing goodies. So what we're really talking about is getting rapid feedback about risk. And I think each of these lines has a specific point that I want to talk about. So let's talk about risk first, like why we're performance testing. So it's an old truism that you can't test quality into a product. You can't. Testing can gather information. Testing addresses risk by giving you more information about what happens under certain conditions with your software. So functional testing, it's pretty easy to create an automated test case. And when I get to this point in my script, if I see this, call it a pass. And if I don't, call it a fail. And this is pretty well understood, I think. In a TDD world, it's pretty simple to understand, and assert measure something pretty easy. Performance testing is a little bit harder to do that with, though. How do we know what to check for? How do we decide whether we've passed or not? I'll get into that a little bit, but I want to also talk about the risks that we're addressing here, because functional testing is it works or it doesn't work. That's pretty easy to understand. A system breaking under some kind of load is a different set of risks, and it can be a bigger risk, maybe, because in the e-commerce world where we do a lot of our business, a slower site is considered worse than a down site. At least a down site, somebody might come back later. A slow site, people will leave forever. They have a poor experience, then they're done. Healthcare.gov is the standard thing to be cited here, that if you give somebody a poor experience with irregular performance, then they will not be back. So the first risk, when people say, oh, I want a load test. Well, why? Well, make sure it scales. Well, make sure it scales to what? What do you mean by scaling? The way I'm describing it is, is this operation too expensive? I have a bucket full of X number of resources, and maybe I can get more buckets from the cloud, but I can only do so many. How do I find those kinds of problems in my performance test? Well, I can look for a longer response time, even if I run a single user. If something takes 3 to 5 seconds with nobody on the system, it's probably not a very efficient piece of code. So this is the kind of risk I can test early on. Now remember, when we talk about testing for the top of the e-commerce market, we're talking about hundreds of thousands of virtual users, farms with hundreds of servers. Usually you don't have that for a test environment. We're talking about with one server maybe, or a couple of servers. So we can't run the same kind of load on it. We can still find an activity that doesn't scale if we're watching carefully. Oh, I'm a big fan of Worst Law, by the way. By putting so many frameworks in between the code that we write and the metal, we've made software slower despite the many increases in power that we've experienced. We can have a problem with capacity. Later I'll talk a little bit more about this, but when you say capacity of a system, people start thinking, how many users can I put on this whole system? Someday we're going to have 2 million customers, and it's going to be awesome. But today, how about 20,000? Can we get that far? And what you find out is even to support a load like that, you're going to talk about horizontal scaling at many tiers. So let's look at what one server can do. If we can get 500 users on one server, then it's possible that 40 will support 20,000. If I can't get that first server filled and have it perform well, I should give up on trying to scale it any farther. This is the kind of thing we can look at. This resource level stuff, the CPU and CPUs, watching that, the network pipes. This is what being a perf engineer used to be all about, which is having these discrete pools of resources. There would only be so much data to a data center. There would only be so much CPU on a box. That's one of the things that's changed a lot in parallel with software development changes is cloud infrastructure. There still is some upper limit. There still is some how much bandwidth you're willing to pay for. There's how many database queries you can run on the infrastructure you have. You can find limits to what your system can ultimately support. In a performance test, we're often trying to find a concurrency issue. When we had to write our own multi-threading code, this came up a lot more often. This can still be a thing if you are trying to do any kind of complicated multi-step data transaction where you have a finite pool of things you're drawing from and trying to record. Sometimes these concurrency bugs are really hard to see. You need the right overlap of execution to have anything occur. And you can really only find them with a multi-threaded test, which is really, all performance test is multi-threaded automation with maybe some less options for what you can do in the test. But the idea is creating a system state where some of these collisions might occur so that you can find out about it instead of your users finding out about it. The other truism in a performance test is that the time when you're at the highest risk of something breaking is by definition the worst time for something to break, because that means that there are the most people using the system at that time. And then there's reliability. I still get a lot of call for this too. People want to know, am I leaking objects? Am I leaking memory? Well, you run a longer test and you can find out. in production, if you're pretty clever and you're Netflix, you get to bring servers up and down all the time and fold them in and remove them from load balancing and recycle them and put them back in. The rest of us mere mortals have to figure out how to just keep some servers running. And understanding how long your processes will run is a pretty important input for that. I was working with a SaaS startup in 2005 where they figured out that they needed 3 hours of scheduled downtime every night so they could recycle all their web processes every night to keep things running. So let's talk about testing. And there's a robot dinosaur, so we're doing a little bit better. This dinosaur is still really dumb, though. That is Grimlock from the Transformers, not to be confused with with fake Grimlock, the startup evangelist. This Grimlock here is really dumb and pushes a button to run lots of tests. He's not dumb for doing that, but he is relying on tools. So luckily, we have a tool, and we got Cascade to write version 1.0 for us. So we have a tool that does a bunch of stuff in Jenkins. That's pretty much how we tell a continuous delivery story, is we bring up Jenkins, and we say, OK, we're at the point where you've pushed to your test environment, and you'd like to run a test, and decide whether or not we go forward. So there's all the different orchestration steps for that. I mean, we have added the ability to start up your test infrastructure and tear it down at the end. These are things that people are handling on their own anyways, but at least we have them as clicks in there. We've got some mobile functional automation commands in there as well. So whenever I talk to a Circle CI customer or a Travis or somebody like that, then we drop back to a conversation about a command line interface, unfortunately. So it's time to talk about testing, and this is where I hope I have something to offer here as studying testing for a while. The idea with testing is we have an idea of whether we're going to test a particular thing still does what we thought it did last time, and then hopefully that's a good enough experiment to tell us whether the software is broken, and that our test doesn't continue to pass even though the software is broken, which is a pretty common thing. The test automation world is actually 15 or 20 years old, and people who do this full time have learned a lot about how to build in abstraction to your automation, about how to add multiple validations to make sure stuff passes. I think that making developers responsible for writing quick and dirty automated tests means that our automated tests are probably more fallible than they used to be. Something to think about. So in evaluating the results from this headless test that just ran automatically, I'm still trying to automatically evaluate, trying to decide, did it pass this test or not? Is it okay to proceed in my pipeline? Now, to do a decent test, I have to decide what I'm going to measure. So in functional testing, it may be, did this piece of text appear? Did this screen appear? Do I see this bitmap somewhere on the screen? There's a number of techniques people are using for doing happy path, positive validation that the right thing occurred. So expected result, reliable measurement, that's pretty easy to understand. Validating that measurement when you're investigating a problem is a little more difficult. Automated testing proposes that you're going to pass these 1,000 fairly easy checks and then you'll be able to move along. The reality is, in a bigger project, stuff breaks all the time. People are having to fix it all the time. So and then while they're trying to fix the build, well, we know that there's no happiness for a bit, and there's a lot of pressure on whoever's checking broke the build. So how do you quickly find out whether you really had an issue? Well, some independent validations are great. Rerunning the test yourself is maybe not so great. Having to step through it with a debugger is even less great, just in terms of speed at which you can fix it. And then this last one is super important for performance testing, but in anything where we're managing state, how can I reproduce the conditions under which I expect this test to run? The data set behind here has to be okay. In performance, it's going to be the resources need to be the same so that I can expect similar performance to what I'm baselining against. If it's the same machine as yesterday, that's cool, then it should work out. So in a performance test, we add some measurement and aggregation. There's different things we're going to look at to decide whether a performance test passes. So resources being reproducible. We might also use compound conditions. So for X load, did we complete this many transactions per second with this error rate? Did we move this much data? And these are all ways that we can verify that our request worked. In the web testing world, many applications will return a 200 HTTP status as they spit out disgusting errors all over the actual page. So that's usually not enough. You need to look at the contents. And in those kinds of situations, the size of the page might be pretty helpful. A lot of you don't work in a web context, so I'll rely on you to fill in your own substitute for the same concept of measuring how many bytes we're moving and how long it takes and how reliably we do that as things that I would propose are evaluation criteria for a load test. The important thing for here is that we can do these things automatically. I can go run this test headlessly, I can go evaluate those conditions, I can go make a determination whether this is a pass or not. So you can do that in your actual integration tool, or you could do, this is how we do it inside of our load tool. We have a couple different things that you can set up as a measurement to pass or fail these results. So I've seen things done both ways where people are relying on our tool to return a failure state, or I've also had people just say, give me response times and I'll deal with it over in Jenkins. So both ways we have to support. So now that we have this idea that we're measuring in multiple dimensions at the same time, we need to be able to make sure that this measurement is reliable. And this is where calibration comes in. So what we're really trying to do in our test is find out, are we slower than yesterday? Are we slower than last week? Are we slower than last month? Or maybe we're better. I mean, hopefully we're better. We're never better. Measuring your results horizontally against each other is a thing that comes up in performance that maybe you don't have to think about with functional when it's just pass or fail. But it may be very interesting that response times are 2,200 milliseconds today and were 1,500 milliseconds yesterday. That's where bloat gets into software a little bit at a time. If it's a terrible problem, you might be able to detect it. So let's run some experiments. I kind of got stuck on this dinosaur thing, I'm sorry. But he is doing science, and that's cool. So let's talk about test design. So back when dinosaurs roamed the earth in 2006, we would try to run these very elaborate, I call them scenario tests, where we're trying to build this dress rehearsal of what production would be like. And we'd have all these assumptions baked in about how we'd have these users doing these things at this rate, and it would all be exactly like production, and therefore would be like really predictive of what was going to happen when we went live. And that's still the way most large-scale performance tests are thought of and constructed, with this idea that we're going to be safe because we're going to put the exact same load on that we expect to do in prod. There's a lot of assumptions built into that, so that should be a good indication that it's pretty much bullshit. That you can't think of everything, you can't create production in your test lab. Production isn't the same thing every day, for starters. But there's many other things going on. There's many other variables. All the guesses that you make about how many users are in there and how long they wait to click between pages and how much each person varies between people. We're making some kind of model that's not going to be very accurate. It's hopefully going to be useful. We've been doing a lot of work to try to take production monitoring and turn that into a load test plan. It still requires some simplification. If you really look at log files, and I have to admit I'm a nerd enough that I've gotten lost in them before and started to see what arrival patterns really look like, they're clumpy and weird in an organic way that you can't really reproduce with an automated tool. And then there's several points here about things that are just difficult to reproduce inside of a tool. It's a problem that all testing has, but it's a little more stark in performance testing, that if we don't test the one function that blocks everybody in the database, then our performance test is useless. Or if we don't test a very expensive activity, if we get our data set wrong and then it seems to be cheaper than it actually is to do things, performance tests can fail terribly. I can tell you that the healthcare.gov was not a performance testing failure. It was a general process failure by a very large contractor. But there have been other instances where large-scale performance tests have said, yep, everything's great, and then you go live and go right on your face because there are things that you're missing from your model. So let's forget some of that pressure, because if we're doing it in CI, we don't need to do all this. We can't do all this. We can't run a CI test every time we do something in production. We don't have the same environment, and there's a million variables there. We don't have the same background activities that production does. There's more variables there. You know, I have a friend who works in capacity at Facebook, and their worst 2 a.m. call, the way she told me the story a couple years ago, was when Justin Bieber posted a picture, and everybody rushed to the one node that this picture was on, and Facebook was down briefly, about 10 minutes. This is the kind of stuff that's happening out there in the real world. Somebody decides they're going to run a report for every month for the last 2 years, and they're going to do them in sequence. Somebody decides that now would be a good time to start searching with just wildcard against your system. And accounting for these random things occurring is not something, we try to get that out of our tests. Remember, we're trying to get back to reproducible? So stop thinking about realism here, and that's really where I'm trying to drive with this. So the horizontal scalability assumption, that's what I was referring to with how much load can I put on one server. So we've already decided that we're going to scale horizontally to whatever X number marketing dreams up. Let's start with one server and figure out what we can support. So just make a test that does that. And you know, the implementation at the load balancing level, yeah, we got to test that later, sure. But with the test you do every day, there's no reason it has to do that. You don't have to have 7 tiers in your test lab. In fact, that makes it more complicated. In this case, this performance test that I'm proposing, it's trying to make something more like a clean room so that your performance tests will reproduce reliably. So no noise on the network, nothing beating up shared resources if you can help it. Try to keep it all fairly simple, actually, because what you're trying to do is detect an increase in response time somewhere, or a decrease in scalability somewhere, or some change from yesterday. So to do calibration successfully, and to be able to trust your test rig, it needs to be reproducible day to day. I like to say that all test automation is a bit like being a spider. You have a web. Those are all your automated tests. And when you feel a pluck on it, you go rush over there and find out what the heck that was. It's the same idea with a performance test. And you'll get exhausted and not be able to feed your babies if you're getting false alerts all the time. You have to know when it's something real is happening or not. So here are some approaches towards some of the risks identified earlier, how to handle them in a CI process. So in scalability, to the test of whether something is expensive or not, if you already have functional tests, just put a timer on there and start logging how long these things take. That's fairly trivial to do. Yet very little functional automation that I've seen actually collects this kind of timing information. Or it collects it and nobody aggregates it. Or nobody looks at it. That's probably the most useful measurement day to day. Are we doing better or not than yesterday? So that would be something I want you to look at. Capacity, so stair-stepping means add a little more load, run for a while, add a little more load, run for a while, until you find the curve, which is the curve in response time. So as you look at, sorry, I'm facing you. As you look at a graph here, here's a response time curve. As load increases, eventually, we call it the knee of the curve, an exponential swing comes up. You run out of CPU, you run out of storage, you run out of network. That place where the curve happens, that's where you're trying to identify. That's your capacity point. So that's how you can find that. And then concurrency, you don't need to pound the system with 1,000 users. You can do it with 10 if you do it rapidly. If you try to collide people. If you do the 1, 2, 3, go and slam them into each other. So you actually find out if you lose yourselves in log files, doesn't sound romantic, is that only a handful of people are interacting with the system at any 1 second. It might be 5 on a system that supports 10,000 users. They're just all kind of evening out over time. So if you can keep creating those collisions rapidly, you can actually test for concurrency much more effectively than a production workload can, or any kind of large simulation-style workload. You create a scrum. See, that's why I always question that term, a scrum, where we're all bumping into each other, not getting very far, expending a lot of effort. And you can find a concurrency bug, perhaps. And reliability, I'm still recommending the same thing. You run a long-term load test. You put it on one box. You run it for days. You run it over the weekend. Run it at 50, 70% of a server capacity, and just watch. And eventually, your response times will increase if you're used up resources, or you'll get a process crash, or your garbage collection activity will start to happen more and more frequently. It's usually not too hard to see. The point is to stack up enough executions that any leak could actually be detected. Okay, so I think what you're asking is if you're running a test all weekend, well, if it's a prod server that you actually have like people logging onto and revenues attached, then you should have the proper monitoring to detect if, well, if it's one test server, who cares? Let it break. That's what you're trying to find out. Maybe if you can come back and the process is in a crash state, you can even take a dump and get some useful information out of it. And maybe I'm misunderstanding your question, though. So the way that we do it in an automated fashion is we'll program the load ahead of time, and then when response time hits a certain threshold, then you say, okay, well then it's too long now. You may want to do that kind of test interactively as you learn an app, and then once you find out where the breakpoint is, then you can reproduce that state over and over again and see if you still find your response time increase at the same point. Yeah, the idea is just to see if I let it run indefinitely, do I see any leaks? I mean, I want to find that in a test environment rather than find it under fire in production. That's my hypothesis. And I don't need a whole production site to find that. I can just do it in the corner of my test lab. Hopefully on infrastructure I don't need for anything else. What you test, I think, changes as well. So these are all methods of deploying load and deciding what to measure. These are methods of deploying load. These are methods of deciding what to measure. I don't think that you have to be realistic necessarily in what you test in your performance test either. Just like your load isn't realistic, I think the functions you test don't necessarily have to be realistic for the purposes of finding out if you've damaged the scalability of your system. So the classic example is login. Some sort of authentication takes place, and then you're authorized for some number of things. And that started out as a 500K construct and is now a 5 meg construct. Can you find that along the way? If your search functionality has gotten crufty, just run a simple search and you should be able to tell. In fact, the simpler the search, the easier it's going to be to tell. And these are things that on an iterative project are going to appear early. So you can actually track what's my session overhead from the moment we had a session object until 6 months from now and identify what's expensive for us to do this way. As you make your architecture decisions, should this be as part of a session object? Should I be looking this up? Should I be caching it? You have data to back that up. And just like I talked about isolating your environment, you're isolating use cases here. I have run very effectively and gathered significant value from just doing a login test over and over again. The last point, the next last point, the asserts that were too expensive in scaled load tests. In a big load test, when you're just simulating the request to the system under test, you really can't do too much with what you're getting back because you have to keep that whole test infrastructure running. And that stuff can be hard to keep running and to keep it a reliable instrument if you use too much CPU. And so there's a cost for every time you snapshot the page. a cost for every time that you run any query, any CSS query against what you're getting back. So generally, you don't do that on a large-scale load test. On a load test this scale, maybe you can do that. And it's a technique from functional testing is to take snapshots or screenshots as you go along. So maybe this is something you can still do under load. And then more than one test. Run a sequence of tests. The dress rehearsal load test that tried to address all of our potential risks all at once was a little too big and a little too fat, and it took a little too long. So we shouldn't do that anymore. Let's run this test, and then run this test, then run this test, and check these risks separately. Because now that it's not 50 people on a call bridge anymore, we can afford to run more and more tests. So what are the new tricks? You know how hard it is to find a dinosaur in a tuxedo? It was pretty hard. So it's still about, I don't think there are new tricks other than how we run tests. What we're trying to do is provide information. Should I go live? Should I not go live? Does this build pass? Does this build not pass? What do I need to tell you to determine that? So I could just show you graphs or traffic lights, and we can go, still looks good. If there's an actual problem, what am I going to tell you then? How am I going to convince you to take action? How am I going to convince you to delay a release? How do I convince the subject matter expert team that handles firewalls that they actually have a problem? So this is where the analytics come in, the ability to gather useful information from your test so that it can be actionable. Because just, red light means, okay, someone has to look at it. It doesn't draw the line the rest of the way to resolving the problem that caused it in the first place. So this is something I talk about endlessly at testing conferences about how to look at performance testing results. For this audience, I'd say you should look at what kind of graphing you can get out of your tool and how you can track over time. So this is when we're returning data to Jenkins. This is the kind of stuff that we're tracing. That's a 90th percentile response time history in the lower right. That's great as a status indicator. I've been in the offices where they actually have the traffic light wired in, and that's all cool until it stays red for 3 weeks and everyone gets pissed off. Some sort of information radiator is awesome. But to get into a real problem, you might need to drill into the analytics inside of a load tool. So the blaze meter people standing there in the back, or us in cloud test, we kind of save your load test results behind the scenes so that when you see a problem here, okay, well, we're going to fall out of the CI process and we're going to go log onto our load tool and look at our results and determine where it is we went wrong. Something to think about. I think that a lot of the CI testing is focused on easy validation, happy path, just say everything's okay so I can get out. Let me dodge around this tree and jump over this hurdle and get out of here, instead of being ready to be resilient and to solve problems. All right, so as I've gotten with the times a little bit more, this is the first mammal that appeared back in the Cretaceous period, so I'm hoping at least I've gotten to here, if maybe not to the full tool-using ape, although I probably look like that to some extent. Thank you very much for coming. I'll present to my conclusions one more time, and then I'll take some questions. So tester for risk. Notice that performance testing risks are different than functional testing risks, and they need to be addressed in a different way. Same as kind of what I'm getting at again with pass-fail. It's a little harder to evaluate a performance test. I've proposed a lot of changes for how you create a performance test in a continuous integration context. I think hopefully that's the value you got from this is, oh, wow, I don't need to find out what our production workload was last Thanksgiving in order to make a performance test for continuous integration. You definitely do not. You need to make a reliable measurement you can take repeatedly and that you trust. And of course, embracing the present beats the alternative. So thank you so much for coming. I really appreciate it. I got a couple minutes left. Happy to take any questions. Okay, so when I started in performance testing, we used to talk about performance monitoring being 3, 5, 7% of a box to put out any kind of real resource data. I think that's a smaller amount these days. It has to be thought of. You have to think about how much data you're logging, And I think we touched on that in talking about what you can assert during a load test, which is a lot less than you can do during a functional test. It is a problem with your instruments where you're measuring response time that if those are overloaded, your results won't be reliable. That's part of having a reproducible, reliable measurement. I really answered your question. Yes, you have to think about that for sure. Yeah.
The microphone. As we talk about continuous integration, performance tests tend to take time. How do you decide which builds to run on? If I'm pushing out builds every 3 or 4 hours, do you decide to do your performance test once a day, twice a day, once a night?
So that's a pretty interesting question. I've seen performance test suites that run in less than an hour. You don't have to run them for hours unless you're trying to do a soak test. You could run them on some different frequency. You could also be running them asynchronously, where at this, early on in the process, I've kicked off a perf test somewhere else, and then I'm continuing down my functional test pipeline at the same time. And I think 4 hours later, I may have a completely new build when I get my test results. Now, that's part of a test infrastructure too, is start and stop and management. 7 minutes? Okay, cool. That as a not a non-DevOps maven or Scrum bag, that's probably, I'm not the expert on how to do all that. Yeah. Well, yeah, I think that's a thing. Some of these tests, these could be 5-minute tests. There's no reason for them to be hours. The classic performance test is usually everyone assumes an hour or 90 minutes. Okay, it gives it time for resonances to work themselves out. But if you're just trying to calibrate against yesterday, maybe you don't need to run a long-term test with 20,000 transactions. Maybe a couple hundred do it for you.
Hey, so, let's just say that you have like a lot of developers and a lot of applications and a lot of, just a lot of movement happening, right? And I'm talking like in the thousands and hundreds, of developers and applications, right? So, practically speaking, you're not going to say, well, there's a dedicated environment for every developer and every application, to be able to do this kind of thing. So what would you recommend for trying to leverage commodity hardware to execute performance testing across a vast, large sea of applications and developers in order to realistically, the most important part of this is to get apples to apples results, specifically when you have a bunch of applications colliding on a commodity hardware, and you can't reliably say that the performance results you get from test run 1 is the same apples to apples comparison as test run 2 when you've got 100 developers doing random things on the box. Does that make sense?
It does. Okay. So I would suggest that an individual team might do their own unit performance testing, and you'd also would do some sort of integrated performance test to create more of those collisions. I think that I would want to know how my team was doing, especially if I'm going to get called on the carpet at some point, day to day. But yeah, I think your responsibility, if you're on a project like that, is to figure out how to regularly test those interactions, so you don't get a nasty surprise like, oh, we're totally colliding on this one service that nobody ever thought we needed to scale up like that. Facebook has some server farms with tens of thousands of servers, and they have some that have like 10. So if everybody's tried to go to that same box, that same service at the same time, you might have some issues.
I apologize if you already covered this. I don't remember it, but recalibration, the daily recalibration, can you talk a little more about specifics on that?
Sure.
How you go about doing that?
So for a calibration run, is my environment the same as yesterday? The simplest load test is probably a good place to start. And you have to have some tolerance of 1% or 2, and not where I'll accept this much variance, but more than that, and I don't have a reproducible environment. And an end-to-end test, a smoke test might be the best thing, where you actually do some sort of database query, for example, and just some way to check that your instrument is still accurate. I mean, my understanding, and I'm not a scientist, a biologist, a chemist, anything like that, but there's a regular calibration of your instruments and make sure they're still working as expected. I think you need to do the same thing with load tests. Now, some of the other dinosaurs who are not interested in becoming mammals yet will still tell you that you can't test in a virtualized environment and will tell you that you can't test with virtualized load injection because you can't get the same results. I disagree with that. I think you just need to have some sort of tolerance band of what you'll accept day to day from a calibration perspective. Is that pretty good? Yeah. Who else? Okay, well, great. Thank you very much for coming. I appreciate you making it. Thanks.